Welcome to the online MOOC course on software engineering. In this lecture, we will be looking into architectural mapping via data flow. So, we will be using data flow diagrams to map with respect to the architecture, the next step in the software development life cycle. So, the agenda for today will start with design process overview, core concepts in design, the fundamentals in data flow diagram, and how it is going to be mapped with the architecture. So, first we will try to understand how it is actually taken forward. So, the first aspect with respect to this architectural design is starts with clarify the stakeholders concern. So, stakeholder are going to be the set of people who are going to have interest in the project. So, they can be customer or client or fellow developers or competitors. So, anybody who are interested in the project are called as the stakeholders. So, the first step in this design process is to clarify the concerns from the stakeholder. So, once all the concerns, which is nothing but the requirements, are being identified, that will be converted to an abstract core concepts. So, here it is abstract because we might not have the entire idea about the project. So, we will be having an abstract knowledge and will try to prepare a format in identifying the process in overcoming that problems. So, here we will just take with respect to the core concepts that have been involved. Once this has been done, once we have an abstract idea of what needs to be done, we will try to synthesize. So, synthesizing here is generating ideas to overcome the problem. So, we will take one concept at a time, one issue at a time, and we will try to generate ideas and try to solve them. So, once an idea has been solved, we will be trying to test that using you will be having a prototype that has been built and that will be tested for correctness. So, this testable blueprint may be accepted, meaning you have passed the test criteria, or may be rejected where the test criteria is not met. So, it will be done in a iterative cycle until this blueprint is tested as passed. So, basically the idea is something like you get the problem, find the course idea behind that, and then we will try to synthesize that by generating the ideas, providing solutions. Then we will create a prototype and that prototype will be tested. So, this is going to be a iterative cycle and that iteration will be completed at one particular point of time when the stakeholders have a good picture of what they have needed. Okay. So, this entire cycle, so it starts with clarify, creating an abstract design, synthesizing the abstract design and completing with a prototype has to be in a iterative format, meaning it will be refined again and again for improvement. So, at each and every iteration we may either add some functionalities or redefine the existing functionalities, making the software to be a next better version. And at each and every time we may need to evaluate it. So, evaluating is meaning we will be assessing that with a test criteria and also validate across the customer requirements. So, this needs to be done for each and every iteration. Only if it is valid and it is assessed as correct, you can move to the next version. So, the stakeholders' requirements are actually the primary important things. So, we have to identify or capture the requirements from different set of stakeholders and that is the primary step. And then we have to make them as measurable requirement cards. So, this is very important. Whenever a requirement has been stated, it is not that we are going to make that as a single list. So that requirement has to be measured. So say for example, when you say you may need to provide access to students as one corresponding requirement, you have to be very much specific in saying how much count. Any requirement should be measurable. Okay, so say it, I'm just giving an example for non-functional requirement. If you want a system to be available, availability can be measured in percentage. So the system should be at least 99% available or 70% available, makes it a measurable requirement. So only if the requirement is measurable, we'll be able to identify whether we have come to that corresponding level. Okay, so that is very, very important, and if it is a measurable requirement, we will have no issues in the scope being creeped out. Okay, and also we can also define all the initial data flow boundaries. Okay, so basically how we can identify these requirements. So one is user stories. So we might have come across this user stories in the early lectures. So this is going to be the functional needs from the user's perspective. Okay, so that is what we call it as user stories. Second kind of requirement comes from the regulatory or the security side of the government policies. So even though you have a set of requirements from the user end, a stakeholder end, if that is going to be not aligned with the government policies like regulatory and security, we cannot consider that. Okay, so that has to have compliance and data protection mandates. As an example, I can say you, if you are trying to build a medical ground application, any data that we are going to use should not be given as public, because any will not be okay with sharing their medical reports. So there is some standards in using the data. Okay, and it should not be given public. So that are some of the data protection mandates that have been given. With respect to medical, we have this HIPAA constraints. And the third one is performance budgets. So even though you don't have any regulatory constraints and the user has set that corresponding requirement, if that does not comes under the budget, or you will not be able to complete that in the given time frame, you may need to think on that. Okay, so we should have a measurable target for the latency and the throughput. Okay, so this is also very, very important. So when I say latency is something like whenever you hit a button in a web app or in a mobile app or something, in what time you get the results back. So this is one example of latency, and throughput is about the performance, how much time you have raised a request and you have got the correct answer. Okay, so there should be measurable targets for that. So when you say latency, it should be in some milliseconds or nanoseconds as per the requirements in the application. And for throughput, it should be in say 99% or 90%, again with respect to the application under your view. Okay, and basically all these are going to fix the data flow boundaries with respect to our data flow diagrams. So here we are trying to significant things with respect to inputs, the set of outputs and the transformation, and this is going to be the basis of the architectural model. So here the architecture that we are going to build will go through a iterative refinement loop, and from the sketches, from the data flow diagrams and all, we will be trying to build a mature architecture through this continuous feedback loop. So first is going to be the context diagram. So if you remember, the level 0 DFD is called as your context diagram. DFD level 0 is called as your context diagram. So it is trying to give you the system boundary. So in your level 0 DFD, you will be having one single process and the set of inputs that this application would need and the set of outputs that it will produce. So, this is all about your context diagram, very abstract level, and it just says who all interacts to my system and how the system is going to interact with the external world. So, this is what is all about your context diagram. Second is a bit deeper, we call that as container diagram. Here you will be trying to say with respect to the containers in which your software is going to belong. So, whether it is going to be a web application or a mobile application or any microservices. So, based on where you are going to use this or deploy this, the application has to be modeled. Okay. So, that is called as your container level diagram. So, here you will have to be a little more deeper with respect to the architecture, fine grained modules will be shown. The third level is your component level. So, this is still more deeper, you will go within the container. So, say for example, if it is a web application, we will identify what all components you will have. So, when we speak about the components, these components could be custom built or you can also use some existing components also. So, there are several components that are available in the market, commercial and non-commercial. So, it is very much good that we can use the existing components and you can do the plug and play applications so that you can reduce time. But maybe sometimes if it is commercial, you may have to pay also. Okay. So, this is going to produce or it will try to give the internal details in the software. So, this is going to be the flow and this is also going to be refined again and again. Okay. So, we will start with the context and we will find which container or containers your software is going to be working on, and for each and every container you will be having a components identified and that will be depicted as a diagram. So, apart from just sketches, we are now going deeper and identifying how exactly the system is going to work. Okay. So, this each and every level it is going to add some information, adds fidelity, and you can also specify some metrics like latency, throughput and fault tolerance, and that has to be continuously checked to guide the elaboration, refactoring and backtracking. So, here elaboration specifies how much level you have to go on. So, when I was trying to say about the DFD, we said that it starts with level 0 and moves on to n levels based on the application. So, normally n is equal to 2, which means that level 2 DFD is followed as a standard. So, how much you are going to elaborate is also have to be checked on. Refactoring. So, what we mean by refactoring? Changing in a particular part of your program or a architecture or a diagram, and that should not influence in some other part, and if it is going to change, you have to change in all the levels where all it is going to change. Okay. So, to be clear, say for example, you have a component. Okay. So, component 1, 2, 3, 4 and 5. Okay. So, assume that component 1 is linked with 2. So, there is some linking from component 1 and 2, and component 4 is linked with 3. Okay, just for an example. So, when you try to refactor is something like a change that is going to be involved in a corresponding module or a component. So, assume that you have an update with respect to component 1, and since there is a link, there is a influence in component 2, when you refactor this component 1, you may also change correspondingly in component 2, okay, such that this change is not going to affect the rest of the modules. Okay. So, where all your change is going to affect, in all the corresponding places we have to change accordingly. Okay. Another crude example that I can give you is, say for example, you have a variable say I, and at later point of time you want to change that variable I to age. Okay. Wherever you have used the variable I, in all the places you have to change to age so that it is not going to affect elsewhere. So, this is a very simple example for refactoring. So, that could also be taken care. So, that should also be checked. Why? Because changing in one place should not be affected elsewhere, and whether it is changed accordingly or not is checked here. Backtracking. So, sometimes there is a necessity of going back, right, going to the previous version or going to another module where this corresponding change has been done. Okay. So, this is also necessary, and this and all will be checked for each and every refinement or iteration. We will go with the next core design principles. So, these are some of the principles that we might have to understand before we go into changing with respect to DFD and the architecture. So, first is abstraction. So, abstraction is a very important property. We might have learned this in object oriented programming already. So, this is something like we are trying to suppress some details from the user in an idea that will not be necessary. Okay. So, that is what we call it as abstraction, the suppression of irrelevant details while retaining essential properties. So, you are just trying to show only the essential things and not showing something which is irrelevant to a corresponding person or to a module. So, anything is considered as abstraction. So, what is the advantage? So, it is trying to reduce the cognitive load. So, whichever is unnecessary or irrelevant, if I am trying to understand that, it is going to affect my cognitive load, right. So, that is reduced, and it is only trying to focus on what and not how, and it is trying to create manageable levels of understanding. Okay. One another example that I could say you is with respect to abstraction. Assume that you have a module in your college. The same application might be used across different people, say for example as a student, as a staff, and as an administrative person. So, each and every role will have different set of screens. It is not necessary that the same screen that is viewed by the student should be viewed by the lecturer or the staffs. Okay. So, whatever is necessary for a corresponding role, that will be shown. Okay. So, that is also called as abstraction. The second design principle is called as your modularity. It is again a very important principle. So, what modularity says is that it is advisable to have a modular design, which means that any module is considered as a set of work, and that should not be very much big also. Okay. So, it is trying to encapsulate or combine the cohesive concepts behind the stable interface. So, cohesion, I will come to this word in the next few slides. So, all the near available concept with respect to a procedure will be bundled and it will be taken as a function. Okay. And this, when you have multiple such functions, you can develop each one parallelly also, instead of just doing it one by one. When you have modules, that modules could be done in a parallel fashion. Okay. So, next is it can also create swappable and reusable units. So, this is also very much important. So, say for example, you are working in say software A, any software, and if you have a module in that corresponding software and it is working fine, you can use the same module in software B also, only if that module is independent. It may receive some input and it may produce some output, but within that functionality it is going to be independent. Okay. So, that kind of modules or a function is called as reusable units. And you can also localize the changes, meaning if you have any updations to those modules, the modules alone needs to be changed, and this refactoring will not be a very big problem. So, this is coupling and cohesion. So this is very, very important with respect to software design and with respect to our exams also. So coupling says how much you are going to be dependent with respect to two or more modules. Cohesion is the relationship within one's self. Okay. So assume that you have a module A and you have module B, okay, and it has several interactions. You are trying to send and receive several information. It is something like you are dependent on B and B is dependent on A, okay. So there is high level of dependency across modules and this is what we called as coupling, okay. There are sometimes we have a single module and this module have interdependencies within itself, okay. So this is what we call it as cohesion, okay. So just think, if you have an example like this where you are trying to interact with another module for lot of time. If you want to change something in A, so you want to change something in A, obviously you might have to change something in B also because it is more or less they are dependent with respect to each other. Assume that there are some other modules, say C, which is dependent on B, okay. So it goes on in a cycle. So when you change A, there is a necessity to change B as well as C. Maybe if there are some other modules extra, you might need to change everything, okay. So this is a wrong principle, okay. So the rule with respect to the software design says that you should have low coupling. So what we mean by that? We have to minimize the interdependency across the modules so that we reduce the ripple effect. So this is what is ripple effect. A, by changing A, you have to change B. Again, you have to change C. So to whatever modules that module is linked on, everything has to be changed. Okay, so that is a very big problem. So we have to maintain low coupling in our software design. So cohesion, we have understood that it is an interaction within the module. So when you have interaction within the module itself, it is not going to have any problem in case of refactoring. So it is good that you should have high cohesion. So you have to maximize the strength of the internal relationships within the module. Okay, so this is always the coupling should be less. The amount of interactions with the other module should be less. The interaction within the module should be high. Okay, and this balance will yield the components to be easier to test, deploy and evolve without unintended side effects. Okay, so why it is easier to test? Because just take the example that we have given in the earlier time. So assume this is an example. So if you want to test A, you cannot test that in idle. You need B and C, correct? So if you cannot test B in idle, you need A and C. Okay. So but in this case, if A is completed, you can test, correct? So it is easier to test when you have high cohesion and low coupling. It is the same reasons for deploying and evolving. Evolving in the sense updation or going for the next version. The next design principle is separation of concerns. So it is something like more or less related to your modularity. So modularity is you might have taken a very big problem and you have segregated that into some modules. So this will say as module 1, 2, 3, 4 and 5, and this separation has to be either vertical or horizontal. So we are trying to understand what we mean by vertical layering. So here as an example, we'll identify this as presentation layer. So first one could be a presentation layer, second one could be a business logic layer, and third one could be a data access layer. So based on this, you can segregate or divide that into modules. Okay. So we'll just take as a example in ordering a product. Okay. So when you want to order a product, maybe you have to first create an invoice. Check inventory. Order product. Add customer. So some examples I have written. Okay. So add customer is something, say for example, just think of any online portal. Okay. So we might have created a login. Okay. So adding a customer or creating a new customer is something related to your UI. Okay. Order a product. So after a customer has been assigned, you might have order for a particular product. Okay. So ordering a product will have its influence in checking the business logic, whether he or she can order a product or not. Okay. And second is creating an invoice. Invoice is nothing but a bill that has been generated for a particular order. So there should be involvement with respect to data access. So ordering a product may also have an influence with respect to data access. And checking the inventory, you are again going for a data access or a business logic. So likewise, by taking each and every module, we might have to segregate them in terms of, say, presentation, business logic or data access, and then proceed forward. Okay. So that we have to allocate at least one reason to change. Okay. In horizontal slicing, we are cutting with respect to some separation. So everything with respect to security as one module, everything with respect to logging as another set of modules, everything with respect to caching is another set of modules. So likewise also we can segregate. So these are something as an example. It is vertical layering or horizontal slicing. So based on the applications, we can either do vertical or horizontal. So it is basically trying to localize the impact and simplify the reviews. So data flow, again we are trying to revisit this again. So it is going to be a network of processes, data stores and the external entities which are connected by the data flows, and it is trying to specify what and not how. Okay. So data flow diagram or the notations, we have the process which is represented as circle, we have data flow represented as arrows, data stores which is trying to say about the databases, and the external entity, if you have, it is going to be in a rectangular format. Okay. So the process, it is trying to transform the data and it is normally named with the verb phrase, and data flow, it shows the movement, how the data is moved from one process to another. Okay. So it is named as a plural noun, and data store is storing the data persistently, somewhere it has to be stored, and it is named as noun, and external entity is represented as a rectangle, either it is a source or sink. So here we have an example here. So context level, we have understood it is a level 0 diagram where you will be having a process and a set of inputs and the set of outputs. Okay. And in level 1 DFD, it is high when compared to level 0. So here you might have order processing system. Okay. So that could be a initial context diagram. So the input could be inquiry or order. and the output could be invoice and the items, just as an example. So, on an order processing system, as a customer, you can either inquire for availability or order the product, and once the order is processed, you will get the items or get the invoice. Okay, so this is the idea in your level 0 DFD. In level 1 DFD, you can expand this context a little bit. So, say for example, you will be having process enquiry. This is actually a module. Process order. This is another process. Okay. So, the customer, when they order, the process order module gets executed and they will either produce a invoice or they will hand over the items. Okay. If the customer has an enquiry, assume there will be a data store. From the data store, they will inquire and they produce a result and you can get the invoice. Okay. So, invoice maybe you can connect it over here. Okay. So, this is a level 1 DFD. In the level 2 DFD, if you consider over here, it is very much given in detail. So, you can have a customer. So, this is the customer. So, the customer will order a product. Okay. So, maybe we will start with customer enquires the product. Okay. So, that is named as process enquiry. So, once the process has been enquired, you will get the information from the item store and that will be given. Okay. In this phase, the customer orders and this goes to the process called as process order, and this will check with respect to the customer details, item availability in item store, and since this is an order, you have to update the information with respect to the customer and which item they have ordered in the order database, which is D3. Okay. And everything is done, the items will be given to the customer along with the invoice. Okay. So, if you check the level of detail, in level 0 it is very simple, you are trying to give all the information and get the output, and level 1 you are trying to be a little bit giving information and it goes on. Okay. So, whenever you move forward in levels, you are trying to give much more detail. So, mapping to architecture, the very important part here, it says about the flow, the transition from the existing DFD to the architecture. So, we have understood that we have process, we have data store and data flow. So, these are going to be the process and these are going to be the data store. D1, D2 and D3 are called as your data stores and all the arrows are called as your data flow. Okay. So, all the process will be converted to a component or the microservice, and data stores to the persistent schema, or if you want you can also go for a cache storage, and data flow, it is the API or the event stream with which you are going to actually move from one process to another. So, it is something like you will be having an API to contact process enquiry or an API to contact your process order. Okay. So, this is actually the main architectural mapping. So, first of all you have to review the fundamental system model, which is nothing but your requirements, and once the requirements is done, we will refine and review the DFD. Okay. Once it is refined, we will determine whether it is having a transform flow or a transaction flow. So, what we mean by transform flow? It will be having a sequence of interaction. It starts from input, process followed by output. Transaction will have more than one flow. Okay. So, we are only concentrating here with respect to translating the transform center by specifying the incoming and the outgoing boundaries. So, you will be having a process incoming and the outgoing boundaries. So, this is what we are trying to isolate, and then we will perform the first level refactoring. So, we understood what we mean by refactoring. So, the second level refactoring is done, and next we will refine the first iteration architecture using the design heuristics. So, we have learned several design heuristics like abstraction, modularization, separation of context, everything, right. So, those kind of design heuristics will be involved and will be taken into the architecture so that we can improve the architectural quality. So, in addition, we have to think about the non-functional constraints as we do in all the other things. So, we have to think about the throughput and latency. So, with which we can either go for a batch processing or a stream in the sense it is going to be real time. So, if you want a latency to be very minimal, we have to go for streaming because we will be taking the input at real time, or it could be request response based systems also. So, based on the necessity of the throughput and latency, we can go between these choices. And with respect to the security and privacy mentioned in the non-functional requirement, we can go for any encryption, access control and auditing. Okay. The data volume. So, when you have a very big data, it is better for going for caching because it will save the data which are used in the near backwards, right. So, this is very important. And next is consistency. So, any transaction, any functionality that has to be taken, it should be consistent because it will determine the transactions and idempotent operations. So, idempotent in the sense it has to be done fully, or if something happens in between, it has to move forward to the previous consistent state 1 or 0. Okay. So, that is very important, and followed by the validation and evaluation. So, whenever you are trying to deliver an architecture at any last step in a process, we have to make sure it is validated. So, we have to trace with respect to the requirements to make sure every flow and process is justified, and verify the capacities and identify any bottlenecks so that the loads are being considered. And if there is any failures, we have to confirm the resilience, the way in which you have come back after facing the failure, and to make it fault tolerance. And evolutionary roadmap, coming to the next level, some versioned data flow snapshots which allow refactoring internals while preserving the external contracts and ensuring the smooth customer experience. So, it is better to save all the data flow diagrams and at least the baseline in the centralized repository like Git, so that it can be used at the later point of time for refactoring, and it is also going to preserve as an external contract. So, as a summary, in this lecture we have understood the overall process, how it goes on, and we have understood the design concepts like abstraction, modularization, coupling, cohesion and all, and that and all is very important when considering a software design. And then we went to the data flow fundamentals, the data flow diagram. We started from level 0, 1 and 2, and how things being added, how the functionalities gets added, and then we finally understood the mapping from the data flow diagram to the architecture, the 7-step process, which is very important, and that ends the lecture. Thanks.